Although the Nazis made a different type of bizarre military technology, the Me-323 Gigant was undeniably one of the most noteworthy. The Gigant was a remarkable achievement in the world of aviation. It included 6 engines, a wingspan of 55 meters, and the capacity to transport 12 tons of cargo. Tanks, artillery, and people were able to board through the doors in the nose of the aircraft to be carried up to 675 miles away. However, it was also a large, ponderous winged elephant that moved very slowly. The Me-323 was essential in providing the Germans with a response to a dilemma that had been bothering them in the early stages of the war. How can we transport a large number of tanks, infantry, and artillery over the English Channel to seize London? When it came to thinking on a big scale, the Nazis left everyone behind. They made the biggest aircraft that had flown during the Second World War as a part of their quest to extend their reach from the Atlantic to Moscow. The gigantic transport developed by Messerschmitt was given the name Me-323 Gigant, which basically translates to giant. So, how did the Gigant come to be? It all started with the glider superiority during the early stages of World War II. The DFS-230 light glider had proven its effectiveness at the Battle of Fort Eben-Emael in Belgium, and it was eventually employed to great effect in the invasion of Crete in 1941. So, the German military demanded a big assault glider for Operation Sea Lion, codenamed for the planned invasion of Great Britain. Hence, the development on the predecessor of the Me-323 started. For the Germans to be able to launch an invasion across the English Channel, they needed to have the capability of airlifting vehicles and other forms of heavy equipment as part of the first assault wave. As the men in the aviation department sat down to sketch the big assault and cargo plane, change of plans took place. But even though Operation Sea Lion was cancelled, there was still a need for a heavy air transport. At this point, the attention was being directed to the impending invasion of the Soviet Union, codenamed Operation Barbarossa. Junkers and Messerschmitt, the Nazi-controlled air and spacecraft machinery companies, were given just 14 days to submit a design for a big transport glider on the 18th of October 1940. The assault function was still given a significant amount of priority, and one of the demanding requirements was that the vehicle must be able to transport either an 88mm gun and its half-track tractor or a Panzer IV medium tank. Junkers took the lead, and the Junkers Ju-322 Mammut was developed into a prototype, but it was ultimately abandoned due to challenges in sourcing the necessary high-grade timber for its all-wood construction. And there was another problem noticed during the Mammut's only test flight: an unacceptably high degree of instability inherent in the design. Thus, the Junkers Ju-322 Mammut was never put into production. The Messerschmitt aircraft that was going to be built first had the name Me-261W, but later it was changed to the Me-263, and later it was given the name Me-321. Although the Me-321 was employed extensively in Russia as a transport, it was never put to use in the capacity that it was designed for, which was that of an attack glider. In the beginning of 1941, in response to comments made by pilots serving with the Transport Command in Russia, the decision was made to manufacture a motorized model of the Me-321, which was given the name Me-323. It was decided to use French radial engines capable of 1,164 horsepower for takeoff, as using the French engines meant that it would not throw any more pressure on Germany's already overstretched industry. The first experiments were carried out using 4 Gnome engines that were mounted to a modified Me-321 wing. This combination resulted in a speed that was only 130 miles per hour, 50 miles per hour slower than the Ju-52 transport aircraft. A fixed undercarriage was installed, which had 4 smaller wheels in a bogie at the front of the aircraft and 6 larger wheels in 2 lines of 3 at each side of the fuselage, partially covered by an aerodynamic fairing, and the smaller wheels were placed on the front of the aircraft. Pneumatic brakes were installed on the aircraft's rear wheels, helping it to come to a stop in fewer than 200 meters. It still required the 5-engine Heinkel HE-111Z Willing or the highly dangerous Troika-Schlepp formation of 3 Messerschmitt Bf-110 heavy fighters and rocket-assisted takeoff to get airborne when fully loaded, so that it could return to base under its power when it was empty. There were 3 different versions of the Me-323 made, named alphabetically from C to E. Each was different from the other based on the defensive covering and its number and type of engine fitted. The 4-engined Me-323C was considered to be nothing more than a stepping stone to the 6-engine D-series. It was obvious that this was not much superior to the Me-321, therefore the V2 prototype became the first aircraft to have 6 engines. It had its first flight at the beginning of 1942 and went on to become the prototype for the D-series of aircraft. The choice of the 6 engines and their specific placement on the leading edge of the wing were made to reduce torque. 3 engines with a counterclockwise rotation were mounted on the port wing, and 3 engines with a clockwise rotation were mounted on the starboard wing. This caused the propellers to rotate away from each other at the tops of their arcs, similar to how the Heinkel HE-177 used counter-rotating twin propellers during its time. In the same manner as the Me-321, the Me-323 featured huge, high-mounted, semi-cantilever wings that were supported from the fuselage all the way out to the center of the wing. The body of the wing was made out of plywood and fabric to cut down on weight and save on aluminum. Meanwhile, the fuselage was formed out of metal tubes with hardwood spars and covered in doped fabric. Plus, there was considerable bracing in the floor to hold the cargo. 2 pilots, 2 flight engineers, and a radio operator made up the crew of the D-series aircraft, also capable of carrying 2 gunners. 2 tiny cabins, 1 in each wing between the inboard and center engines, were designated as living quarters for the flight engineer. The good thing for the pilots was that they had the option to roll back the decisions that were made by the engineers regarding engine and propeller control. The engineers were supposed to monitor the synchronization of the engines so that the pilot could fly without being concerned about the engine's state. Around 12 tons was the maximum payload the Me-321 could carry, but to take off, it needed the liquid-fueled, rocket-assisted takeoff units that had been designed by Helmut Walter Werke and were installed on the aircraft. The rocket-assisted takeoffs were attached to the underside of the wings inboard of the engines. The wings had underneath fittings that could accommodate a maximum of 4 rocket-assisted takeoff units. Early variants of the Me-321 were equipped with wooden 2-blade propellers, which were eventually replaced with metal 3-blade variable pitch versions. Some Me-321s were modified to Me-323s, but most of them were made from the start as 6-engine aircraft. At a height of 1 mile above sea level, the Me-323 was only capable of reaching a top speed of 136 miles per hour. It was mounted with 5 13mm MG-131 machine guns that could fire from a rear position behind the wings as well as from the fuselage, and were used for defensive purposes. They were operated by the extra gunners, radio operators, and engineers. After being carefully designed and produced on a large scale, it was time to throw them onto the battlefield. In 1940, the Me-323s were being shipped to be used in the Tunisian War. In November of that same year, they were sent to action in the Mediterranean. Because of the high rate of casualties among Axis ships, it was crucial to undertake a massive airlift of supplies over the Mediterranean to help keep Rommel's Africa Corps supplied. On the morning of April 22, 1943, 7 squadrons of Spitfires and P-40s were sent to intercept a group of 27 fully loaded Me-323s that were being escorted over the Sicilian Straits by Bf-109s. 21 of the Me-323s went down in flames, while the escorts only managed to bring down 3 of the P-40s. The design of the Me-323 was such that it was exceedingly durable and could withstand a significant amount of hostile fire, if it was not loaded down with barrels of gasoline. Its hard structure was because of the thick wooden frame of the aircraft. Only the cockpit, the fuel tanks, and the engines were critical locations that had the potential to make the aircraft impossible to control. Due to its slow speed and poor maneuverability, the Me-323 was little help to its pilot in fending off the hostile fire. The defensive machine guns and cannon mounted on board were obviously helpful in keeping opposing fighters at bay, but their range was limited to a certain point. Still, with so much artillery, but because of its enormous size and poor speed, the Me-323 was a classic example of a sitting duck. However, no transport aircraft can ever be expected to survive without something close to air superiority, and it is believed that none of the Me-323s survived in service beyond the summer of 1944. Before production was finally stopped in April of 1944, a total of 198 Me-323s had been built. Beginning with the D-1, there were many manufacturing variants of the aircraft. Improvements were made to the structural strength, overall cargo weight, and fuel capacity of later D and E variants. Despite this, the power output of the Me-323 was far below expectations. The installation of 6 BMW 801 radials was proposed, but unfortunately, it did not take place due to a lack of funding. With a range of about 620 to 750 miles, the Me-323 was another short-range aircraft. But the small number of Me-323s that the Germans had in their service proved to be a very useful asset and was put to extensive use. After the end of World War II, the use of the military transport glider quickly went out of style. The Gigant was, and is likely to continue, to be the world's biggest aircraft that did not have a propulsion system. Well, some achievements are simply not worth surpassing. Planes that hailed from beyond the Iron Curtain weren't generally known for their good looks. On the far side of the outdoor air park at the Polish Aviation Museum in Krakow, you'll find a very strange piece of aviation history. A jet-powered, twin-boom biplane that looks like something out of Frank Herbert's Tales of Dune. What is it? This large, awkward-looking plane is a PZL M15 Belfagor plane, which was designed and built in Poland in the 1970s. Designed more for its functionality and practicality than its aesthetic appeal. Perhaps that's why, of all the eyesore aircraft from the Warsaw Pact countries, the M15 Belfagor reigns supreme. Horrendously ugly. The PZL M15 Belfagor has been called both the world's slowest jet and the heaviest biplane. Take a look at the PZL M15 Belfagor, the first and only jet-powered biplane and agricultural aircraft in the world. Not quite sizzling, is it? The PZL M15 was designed as a part of the Soviet economic strategy in the 1970s to replace the AN-2 NATO codenamed Colt biplane in the vital role of maintaining the enormous wheat fields of Ukraine and Poland, which provided the bulk of the Soviet Union's food supply at the time. A Polish government aircraft agency developed the M15 as a crop duster, but it was a huge disappointment compared to its 1950s-era AN-2 Colt predecessor. Eastern Bloc countries like Poland, Belarus, Ukraine, and Russia used to produce a lot of grain, which was one of the bloc's most valued goods. So, it was important to keep pests under control to avoid a food shortage. Throughout its production run from 1947 to 2002, the Soviet Union cranked out more than 18,500 AN-2 utility biplanes, many of which were used for pesticide spraying. The AN-2 below was designed by the Antonov Design Bureau and could transport up to 12 passengers over a distance of 525 miles. In 1971, Poland's WSK Mielec started making a new gun to replace the Colt. While it never succeeded, it did produce something. The result was the M15. Poland's M15 aircraft was an effort to build something better than the AN-2 while keeping some of the AN-2's attributes. Like the AN-2, the M15 was also a biplane, though It traded a propeller-based turboprop engine for a turbofan-based jet engine. The Belphegor was able to store just under 3 tons of pesticides into enormous pylons that were located between its 2 wings and sprayed using compressed air. The engine was put up high above the system for releasing chemicals so that the emissions from the engine wouldn't mix with the pesticides. Interestingly, the M15 specifications were handed down from political leaders within the USSR. The M15 was to be the people's crop duster of the future, meant to embody the rapid progress of socialism. The goal was to combine cutting-edge technology to make the most effective crop duster the world had ever seen. Since jets were seen as the future of aviation at that time, any possible next-generation crop duster was politically bound to adopt jet propulsion. It also turns out that the Politburo, or Political Bureau of the Central Committee of the Communist Party of the Soviet Union, didn't know that jets are terrible at tasks like crop dusting. Polish designers of the PZL M15 didn't want to jeopardize their fledgling autonomy from the Soviet Union's main aircraft manufacturing center by making a plane that wasn't up to snuff, so they started sketching up the monster that would become the M15. Polish engineers knew it would be hard to put a heavy jet engine in a slow, low-flying plane, so they came up with a solution quickly. Ironically, it was inspired by the AN-2, which the M15 was meant to replace. As a biplane, the M15 would actually generate lift, and the engine would be mounted on top of the fuselage to shield it from potential damage. The basic concept behind the M15 was to construct a crop-dusting aircraft around a standard Soviet jet engine in the hope that it would prove to be more effective than the AN-2. But the Polish plane had several faults from the beginning of production, with some being more problematic than others. The M15 was an unwieldy beast that didn't seem like it belonged in the air or on the ground, and so failed to keep the traditional biplane aesthetic of the AN-2. People hated the way the M15 looked and christened it Belphegor after the biblical demon of greed. Not a great start for the new workhorse of the USSR's breadbasket. It's not hard to see why the Belphegor is so unattractive. It has 2 sets of wings joined by a hollow fuselage and 2 hollow apple-shaped pillars. Crop dusting chemicals, as we said, were stored inside the hollow pillars, together with the pressurized air system that is used to distribute the crop dusting chemicals. Looks and crop dusting aside, jet engines are much harder to maintain than the AN-2s that agricultural aircraft mechanics were accustomed to in the late Soviet era. Even when mechanics were trained to maintain the M15, the Soviet supply system frequently left them short on parts, causing them to spend a lot of time on the ground rather than in the air. Needless to say that the aircraft the M15 was meant to replace, the AN-2, had none of these problems whatsoever and continued to serve the same role during the same time period. Most of the time, the plane was flown by a single pilot, but it had room for 2 or more technicians. The Soviet Union planned to produce hundreds of these planes because of their high hopes for them. The prototype flew in 1974, but manufacturing didn't start until 1976. But after much anticipation, the M15 was a huge letdown. Given its terrible design, one aviation website wondered aloud, is the PZL M15 Belphegor the world's slowest jet or the world's heaviest biplane? Spoiler, it was both. Countless problems plagued the M15. It could go no more than 215 nautical miles, or about half as far as the AN-2. Especially at out-of-the-way airstrips in rural agricultural regions, the turbojet engine proved more challenging to repair than the turboprop of the AN-2. Pilots had to be retrained to fly an airplane with the turbojet engine, which slowed down the change and made it harder. Finally, the jet-powered Belphegor was costly both to manufacture and maintained in the field. The aircraft's unusual method of storing pesticides was another design error that severely limited its potential. The AN-2 carried insecticides in a tank in its fuselage, providing ample cargo area for the aircraft to operate on all sorts of varied duties. But the M-15's insecticides were kept in the pylons, which shrank the plane's fuselage and restricted its capabilities. The Polish plane was effectively typecast as a liquid spraying aircraft, and there weren't many uses for such planes beyond pest control. For a jet, it's hard to beat the lift that the M-15 airframe provides on its own. It's also hard for most jets to go as slowly as the M-15 does without stalling. The M-15 cruises at roughly 80 knots and stalls around 58.5 knots. Unfortunately, the agricultural workers who were tasked with actually piloting the M-15 had little experience with jet aircraft and were more used to more forgiving propeller-based biplanes. So, early M-15s suffered from extreme abuse and couldn't ever get the maintenance that they needed afterward. Predictably, this led to even more time spent on the deck rather than dusting the crops. Far too late, civil aviation authorities realized that agricultural pilots would need extensive retraining to make the switch to using the M-15. Many pilots, even after just a short time flying the M-15, were able to point out its shortfalls compared to the simpler aircraft they were used to flying. The M-15 was more difficult to control than the AN-2, which was considered obsolete politically, and it did not provide much greater payload capacity or range. When it did its job, the M-15 was a crop duster that was expensive, loud, and over-engineered, and it was always compared to its better predecessor. Only 175 PZL M-15s were manufactured, despite an initial production run of 30,000. The M-15 was criticized for all of these reasons before it ever left the prototype stage. Thus, the fact that so many were made is remarkable. Unfortunately, politics seem to have come before good jet design, and for years, an unsuccessful aircraft was compelled to dust the crops out of stubbornness. In a strange turn of events, as the manufacturing of the M-15 stretched on, more and more AN-2s were ordered and adopted for the duty of crop dusting. The aircraft that the M-15 was supposed to replace ended up giving it a run for its money, and as a result, manufacturing of the M-15 was finally halted in the face of this reality. Besides being very ugly, the M-15 was an oddity. Considering that most airplanes have at least a few positives, it's quite an achievement that this one has none. No wonder the Belphegor was reportedly nicknamed after the biblical demon of greed. Maybe no other aircraft, among the hundreds that have been made since Orville and Wilbur Wright first took to the air in 1903, are as hideous as the M-15, which raises the question, did Polish aircraft designers, dissatisfied with Soviet dominance of their country, deliberately design and build a lemon as an act of protest? If WSK Mielce's intention was to produce a failure, it clearly succeeded. Japan did not enter World War II as it broke out, but with the Japanese assault on Pearl Harbor on December 7, 1941, everything changed. This move spurred the United States to declare war on Japan, and shortly after, other allied nations did the same. Over the following 4 years, Japan would be a major player in the war, participating in a wide range of missions across Asia and the Pacific, which meant the need for new fighter aircraft like the Ki-1 and Ki-2. But to understand why these aircraft never had success in World War II, we need to lapse back 10 years from the harbor attack, when in February 1931, a group of private sponsors purchased a Junkers K-37 bomber and donated it to the Japanese Army as Aikoku No. 1, or Patriotic Gift No. 1. After putting this aircraft through its paces in battle in Manchuria, the Japanese Army was so impressed with its performance that they decided to place an order for more aircraft just like it. Mitsubishi's collaboration with Junkers dates back to 1928, when the two companies started adapting the Junkers G-38 4-engine passenger aircraft into the Ki-20 Army Type 92 heavy bomber. The first of these aircraft was completed in 1931, and this experience may have played a part in Mitsubishi being awarded the contract to produce a heavy bomber based on the K-37 in April 1932. The Army gave Mitsubishi detailed instructions on what to make. It was planned as a twin-engine monoplane with a combined 800 horsepower, but it could take off and land with just half of that power. The standard bomb load was set at 2,200 pounds, while the maximum bomb load with less fuel was 3,300 pounds. It was supposed to have a peak speed of 150 miles per hour and be able to operate between 3,280 and 6,560 feet in altitude. It was planned to carry 3 7.7mm machine guns. The Japanese manufacturer responded with a bigger take on the K-37. With its two 701 horsepower Mitsubishi HA-22 water-cooled V12 engines, the Mitsubishi Ki-1 was a low-wing, cantilever monoplane that could reach a top speed of 222 km per hour or 137 miles per hour. Gunners were stationed in the semi-enclosed nose and dorsal gun turrets, each of which was mounted with a single 7.7mm machine gun. The pilot and co-pilot were seated in pairs below an enclosed canopy. The maximum bomb load that could be put to use was 1,500 kilograms or 3,307 pounds. The Ki-1 was based on the Junkers S-36, which made its first flight in 1927 and was later militarized by Junkers' Swedish affiliate AB Flugindustri at Limhamn near Malmö to become the Junkers K-37. It could fly higher than any of the other planes of 1927 could have dreamed of going. But by 1930, the British had caught up with them because innovations like the Bristol Bulldog fighter and Junkers' design had fallen out of favor. However, in 1931, Mitsubishi officials from Japan came to Limhamn to learn more about the company's work modifying Junkers planes for military use. That's when the Seoul K-37 prototype SWABP, as well as development papers, were purchased in part by funds raised by donations in Japan. The aircraft got the name Patriotic Gift. The first mock-up was finished in August 1932, and the prototype was successfully finished on schedule in March 1933. Since the Mitsubishi Type 93 engine was running behind schedule, it was powered by two Rolls-Royce Buzzard engines, each producing 800 horsepower. Unfortunately, the prototype could not fly with only one engine and was 12 miles per hour slower than intended. Despite these issues, the Type 93 heavy bomber was approved for production by the Army. The K-37 prototype was brought to Japan and tested in combat during the Manchurian Incident of 1931. The Imperial Japanese Army Air Force authorized Mitsubishi to produce both heavy and light bomber variations. Heavy bomber Ki-1 made its first flight in August 1932. It was much bigger than the original Junkers K-37. The Mitsubishi Ki-1 was also designated Mitsubishi Army Type 93I Heavy Bomber under the long aircraft nomenclature system used by the Japanese military. Although it was already out of date when it was introduced, it saw service throughout the pacification of Manchukuoku's counterinsurgency operations and the Second Sino-Japanese War. But that meant new improvements had to be made. So the design was improved to the Mitsubishi Ki-1-2, also known as Mitsubishi Army. These planes had a longer cockpit canopy that went over the dorsal gunner's position, engines that were mounted lower, and smooth panels on the wings instead of corrugated ones. Type 93-2 heavy bomber with a stronger airframe and somewhat more powerful 723 horsepower Mitsubishi HA-23 V12 engines, which boosted the maximum speed to 230 km per hour or 140 miles per hour. Despite the upgrades, the Ki-1 remained underpowered and had trouble staying airborne on single-engine flights, which became a major problem throughout the aircraft's actual duty owing to the engine's unreliability. Eventually, the Fiat BR20 would take its position in the market in 1937. From 1933 through to 1936, a total of 118 airplanes were manufactured. Most of these were Ki-1 Mark Is, but later aircraft were completed as the improved Ki-1 Mark II. Although both Ki series saw action in the Battle of Manchuria in northern China, the Ki-1 was not judged to be a successful aircraft. The Army Airmen liked the Mitsubishi Ki-1 II Type 93 twin-engined light bomber because it was easier to control and faster, but still outdated. So in 1936, the Japanese Army released the requirements that would eventually become the Ki-21 Type 97 heavy bomber, Sally. Around the same period, the military also bought 100 Fiat BR-20 bombers, which temporarily supplanted the Ki-1 as the Type 1 heavy bomber. The Mitsubishi Ki-2, unlike the Ki-1, actually had a lot in common with the K-37. It was about the same size and weight as its predecessor and shared the Junkers Ju-52 transport plane's signature corrugated wings. When the original Nakajima Jupiter engines were swapped out for 750 horsepower Mitsubishi HA8s, the performance of the plane got a lot better. Ki-2 was designated Type 93 light bomber when it entered service. By the time of the Sino-Japanese War, the Ki-2 had become almost as obsolete as the Ki-1, and newer variants like the BR-20 and Ki-21 had begun to replace them in service. By the time of Pearl Harbor, the type had been entirely withdrawn into training roles. The Allies, believing a few of the type might still be used in combat, assigned the reporting name Louise to the bomber in 1942. At least 2 squadrons of Ki-2s took part in the fight of Zhuzhou, making it clear that this plane saw more action than its predecessor, the Ki-1. Over the years, however, many of these Ki-2s were shot down in the air or on the ground, and the handful that remained were retired from active service. If the Ki-2 is remembered at all, it will be the plane that inspired a civilian plane to break all known speed records. The Asahi Shimbun newspaper ordered an unarmed version of the Model 2 variant. Named the Otori, or Phoenix, it was equipped with a new cockpit and dual controls, and its fuel capacity was increased. It made many long-distance flights, including one that encircled China at a distance of 9,300 kilometers between 1936 and 1939. Although this spin-off is interesting, neither the Ki-1 nor the Ki-2 would go on to great things in and of itself. There was a time when their designs may have been called cutting edge, but like with many innovations from the early 1930s, they quickly became outdated. When the Ki-1 was only beginning its duty in the military, the prototype for the Ki-21 had already made its first voyage. Even this was a creation of the design team at Mitsubishi, and its lightning-fast speed and streamlined appearance were evidence of the significant advancements that had been made in aircraft design. Unlike the Ki-1, this aircraft would see extensive service, being operated from 1938 all the way through to 1945. But the history of the Ki-21 is a story for another day.